Welcome everyone. Today we're going to be doing the DL of tangent x times sinus x. We have to calculate the DL au voisinage de 0 à l'ordre 5. So that means for when n is equal to 5, what is the DL of this function tangent x times sinus x? If you're just joining for the first time, I already have a video where I treated how to multiply DLs and the whole introduction to Developpement Limited. So you get to see that in the description below. So to be able to find the DL of tangent x and times sinus x, we have to know the DL of tangent x and the DL of sinus x. So once again, I'm going to put in the card above, so you can click on it and then you go to where I explained how to derive DLs from other basic DLs. So the DL of tangent x is x plus 1 over 3 x raised to the power of 3 plus 2 over 15 x raised to the power of 5 plus epsilon petit e de x5. This is to the order of 5. So this is the DL of tangent x to the order of 5, and the DL of sinus x to the order of 5 will be x minus 1 over 3 factorial x raised to the power of 3 plus 1 over 5 factorial of x raised to the power of 5 plus x raised to the plus petit e the x raised to the power of 5. Now we said for sinus x is gotten from exponential x, which I explained. I said that sinus x, the DL of sinus x can be easily gotten from exponential x, such that we take only the odd powers from exponential x to be able to get the DL of sinus x. So up to the order of 5, that's what we've done. So I'll put a link to that particular video so you can watch and then understand how we got this. For tangent x can be gotten from the DL of sinus x over cosinus x, because we know tangent x is sinus x over cosinus x. So to get the DL of tangent x, we can get that by doing sinus x over the DL of cosinus x to the order that you want, and then you'll be able to get the DL of tangent x. If not, these DLs that I've written here, they are basic DLs. That is to say, you don't have to show how you got them, because they are already in what we call the basic DLs. So the DL of tangent x is x plus 1 over 3 x raised to the power of 3 plus 2 over 15 x raised to the power of 5. We are stopping at 5 because the question said we should go to the order of 5. That is for when n is equal to 5. Same thing for sinus x, x minus 1 over 3 factorial x raised to the power of 3, sorry about that, plus 1 over 5 factorial x raised to the power of 5 plus petit e x raised to the power of 5. So now, in order to get the DL of tangent x times sinus x, we multiply these two DLs that we have right here. That's this and this. So we have tangent x times sinus x, which is f of x, will be equal to, so we take this and multiply it with this. Remember, we are going to the order of 5. So even when multiplying, we have to stop at the order of 5. As I said before, that if you are multiplying or you're doing any operation and you see that the passes 5, in this case 5, the passes the end that you are giving generally, but and in this case 5, you have to stop. The ones that are after that are like from 6, 7, 8 and so on, we'll all put them in what we call our rest, which is our petito de x raised to the power of 5. In this case, everything will go to the rest. So multiplying this, we are going to have x, I'm writing this expression again, plus 1 over 3 x raised to the power of 3 plus 2 over 15 x raised to the power of 5 times, we are writing the one for sinus x right now. So the one for sinus x, you can see here that this is a 3 factorial, and we know that we say that factorial is, let me say for example I have a factorial of 3, is the same thing as me saying 3 times 2 times 1. If I have a factorial of, let's say, okay, let's use 5 right here as well. I'll do it right here. It means 5 times 4 times 3 times 2 times 1. So factorial of 4 will be 4 times 3 times 2 times 1. So that's just the logic. You get the number, you keep multiplying it down till you get to 1, and you multiply all of them together. So in this case we have the factorial of 3 and the factorial of 5. So the factorial of 3 is 3 times 2 times 1. So we pick the sinus x, which is x minus 1 over 3 factorial. So this is 3 factorial, so we'll multiply 3 times 2, which is 6, times 1, which is 6. So 3 factorial is 6. Then we have our plus 1 over 5 factorial, that's this right here. 5 factorial, that's 5 times 4, which is 20. 20 times 3, which is 60. 60 times 2, which is 120. 120 times 1 is 120. So this will be 120. So we replace our 5 factorial with 120. So we have x raised to the power of 5. Oh, sorry, I missed an x raised to the power of 3 right here. Alright, cool. So 1 over 20 x raised to the power of 5, and we multiply. So multiplying this, we are going to multiply this x, use this x right here, and multiply everything in the second part. And remember, we are going to the order of 5, so we multiply. If we find an order that is more than 5, we don't add it to our calculation. So we have x times x, so we start from here, x times x, that is x raised to the power of 2. X, this same x right here, x times minus 1 over 6 x raised to the power of 3. So I'll do this right here. X times, we said minus 1 over 6 x raised to the power of 3. So it will be x raised to the power of 3, that's x raised to the power of 4. So that's minus 1 over 6 x raised to the power of 4. So minus 1 over 6 x raised to the power of 4. Now x times 1 over 120 x raised to the power of 5. Okay, so they have the same variable. So x raised to the power of 5, that's x raised to the power of 6. So that's, you don't add it to this because it's more than the order that we've been given, so we don't put it. It's going to just basically be in our rest, which will be our petit e to x raised to the power of 5. So now we're done with the first x. Now we'll move to the second one. So we have 1 over 3 x raised to the power of 3 times x. So that's 1 over 3 x raised to the power of 4. Then again 1 over 3 x raised to the power of 3 times minus 1 over 6 x raised to the power of 3. Now we see 3 and 3, so that's going to give us 6, so we can't add it to our DL. 1 over 3x raised to the power of 3, we multiply it with the last one right here, and we see this is going to give us 8. 5 plus 3 right here, because if we multiply this, we're going to get an order that will give us 8, and we don't need that in this question, so we don't add that as well. So we come here again and we check 2 over 15. Now we're done with this second part right here. We've used this to multiply here. Now we are left with this one. So 2 over 15 x raised to the power of 5 times x. Now we see this is going to give us an order that is greater than 5. So we don't put it, because 2 over 15 x raised to the power of 5 times x will be 2 over 15 x raised to the power of 5, because you know there's a 1 here, so it will be plus 1, so it gives us 6. From that's gotten from the concept where we have, if we have xa times xb is the same thing as saying xa plus b. So 1 over 3 x raised to the power 2 over 15 x raised to the power of 5 times x raised to the power of 1 will give us a power that is greater than 5, which is 6, so we don't need that as well. So finally, this is what we're left with. Okay, so we have x raised to the power of 2. Now we have 1 minus 1 over 6 x raised to the power of 4 plus 1 over 3 x raised to the power of 4. So they have the same power, so we can perform an arithmetic operation here. In this case, it's going to be addition. So we're going to have 1, I'll bring this positive first, 1 over 3 x raised to the power of 4 minus 1 over 6 x raised to the power of 4. And to have the common denominator, we're going to have right here, if I multiply here by 2, I'm going to have 6. So when doing this, we have to look at what can I multiply that will give me the same denominator. So in this case, I can't multiply anything to 6 that would give me 3, but I can multiply something to 3 that would give me 6. So that's why I multiplied here by 2 to give me 6, so I can have the same denominator. So the LCM here is 6. So whatever I do to the denominator, I have to do to the numerator as well. So since I multiplied here by 2, I have to multiply here by 2. So this is now 6. So we have a common denominator of 6. So I'll do that right here. We have a common denominator of 6. And so we multiply what we have left at the top minus what we have here. So I have 1 times 2, which will give me 2x raised to the power of 4 minus 1 times x raised to the power of 4, which will give me x raised to the power of 4. So this is 2 minus x raised to the power 2x raised to the power of 4 minus x raised to the power of 4 all over 6. So that's going to give me x raised to the power of 4 all over 6. So the sum of this will give me plus x raised to the power of 4 all over 6. So remember when we were multiplying, we found some orders that were greater than 5. So we're going to place everything there. I use a blue pen for it. In a petit 2 de x raised to the power of 5. So this is our final answer. So the DL of tangent x times sinus x to the order of 5 over zinage to 0 is x raised to the power of 2 plus x raised to the power of 4 over 6 plus petit 2 to x raised to the power of 5. Thank you for watching. If you have any question, you can place them, you can put them down in the comment section below, and I hope I'll be available to answer your questions. So thank you for watching, and see you in the next video.